Hello everyone, welcome to the channel. In this video, we will see how D'Alembert's principle and Newton's second laws are used to solve system of pulleys problem. The problem states that in the system of pulleys, the pulleys are massless and the strings are inextensible. Mass of A is 2 kg, mass of B is 4 kg and mass of C is 6 kg as shown in the figure. If the system is released from the rest, we have to find tension in each of the three strings and acceleration of the masses. Okay, so to solve this kind of problem, we have to frame or else we have to find kinematic relation between the blocks, because if you see, all the blocks are connected by a string which is inextensible. Okay, so the relation will be in terms of displacement, velocity or else acceleration. To find the kinematic relation, we can introduce tension in the string or else cord. After that, we can apply virtual work principle. So which states that virtual work done by internal force, that is string, is 0. Okay. So by using this information, how you can solve this thing? So first of all, I'll write down the given data first. Given data. Here mass A equal to 2 kg, mass B equal to 4 kg and mass C equal to 6 kg. Okay. Now we have to frame the kinematic relation. To frame the kinematic relation, we are going to introduce the tension. Okay. So by the block 2 kg, we'll have a tension in the string like this in the upward direction because it is hanging downward. So we'll have a tension in the upward direction, and to stabilize it, so we'll have a tension in the downward direction as well. This is the T by the block A, and similar manner we'll have a tension in the B block as well like this. Here also we have a tension T by the B block. If you see, we have two tension in this pulley. Okay, so we have two tensions in this pulley, tension from the block A and tension from the block B. So this will be equal to, here we'll have a 2 tension 2T, and similar manner it will be acting downward as well. So to in 6 kg also the same thing is acting, so similar we'll have 2T as well. Okay, so now we have introduced the tension in this string. So we know that work done will be equal to force into distance or displacement. So you have to find the distance. Suppose if I am taking this as a reference point, from the reference point, how much distance this 6 kg has moved. So this can be taken as xc, okay, or else sc. And in the similar manner, this pulley also moved some distance, so even this will be the same thing. This also in xc, and from this pulley this has moved till xb, and even this has moved from here to here, xa, right? So we have tension and displacements. We have tension and displacement for each block. So we know that work done equal to force into displacement. So by using the note virtual principle work, what we can do is, so we can frame the kinematic relation. Okay, so to find, we have to find what are things we have to find. The first thing is tension in each three spring. Second one is acceleration of the masses, that is a suffix a suffix b, okay, and a suffix c. So you have to find this many acceleration for all the blocks. Okay, so already we have initiated that. So first one is a kinematic relation. We have to apply the virtual work principle. By that, work done is equal to force into displacement. I'm taking here displacement as x, so it states that work done equal to 0 by the tension. Okay, So we have to frame the equation. That means work done by the block A will be equal to T into X suffix A. Okay, plus we have work done by block B as well. If you see, we have a work done by block B, tension into XB, and similarly for tension into XC. So these are the work done by block B and block C. So we have to add it up. So tension into XB plus 2 times of tension into XC. So this will be equal to 0 because it says that internal and work done by the internal force is equal to 0. So we are equating this equal to 0. Now what I'm going to do is I'm taking the T as common because T is a constant, whereas XA, XB are variables. Why variables? Because it will change with respect to time. If anything moves up and down in the pulley, so the distance will also vary. If you see, the distance will vary with respect to time. Okay, it can go down, it can go up as well. So that is the reason it's a variable one. So here the T is a constant. I'm going to take all the T as a common T. So here we are left out with XA plus XB plus XC. Okay, sorry, it's 2 times of XC. Don't forget that 2 times of XC will be equal to 0. Now I'm taking this T to the other side, it will become 0. So the remaining equation will be XA plus XB plus 2XC. If you see, this is our equation of kinematic and it's in the form of displacement. So what I'm going to do is I'm going to differentiate with respect to T. Why I'm differentiating? Because if I differentiate this with respect to T, I will get VA plus VB plus 2VC equal to 0. Again I'm differentiate with respect to T, I will get the acceleration. For this purpose, I have used this equation to get the acceleration. A suffix A plus AB plus 2 times of AC will be equal to 0. So this is our main equation, the first equation. Okay. Okay, now we have to find the acceleration of A, acceleration of B, and acceleration of C. After finding all this acceleration, we have to put it in this equation. Okay. Now, how we are going to find out this acceleration is, we have to consider the FBD for, consider FBD of block A and block B and block C, like that for block A. So if you see, we have a block A. Okay, so here we'll have a tension because it's acting upward. Here we have a tension and the weight of the block will be acting downward. This is 2 kg, so I'm converting into Newton. 2.2 into 9.81. Now I'm assuming all the acceleration upward. Okay, I'm assuming all the acceleration upward, so positive value. I'm assuming here all the acceleration of the blocks are upward. Okay, A suffix A is upward. I'm assuming it. So if I'm taking here, you can see only vertical force are there. So I'm taking F of y will be equal to m into ay. So instead of ay, I'm writing A suffix A. Okay. So F of y is nothing but all the vertical forces, that is T is acting upward. Then minus 2 into 9.81. This is the weight. This will be equal to mass of the block A is 2 into A suffix A. Okay. I need the equation in terms of A acceleration because we have the first equation as A suffix A plus A suffix B plus 2AC. So I'll keep the equation in terms of A suffix A. So A suffix A will be equal to, so this 2 will be come under here is divide. That means T divided by 2, it is 0.5 T. Okay, minus that this 2 and this 2 will cancel. So it will be 9.81. So this is my first equation from the block A. This similar manner, you have to frame the equation for block B as well. Consider FBD of block B. Here also we'll have the tension. The tension will be in the upward direction. The weight will be acting downward direction. The weight of block is, I guess, so 9.81 4 kg. Tension is T, and here also I'm assuming the acceleration in the upward direction. I'm just assuming it. Okay, so similar, f of y will be equal to m into ab. Okay, so all the vertical forces here, so that means t minus 4 into 9.81, this will be equal to m is 4 into ab. So I need the equation in terms of AB. So AB will be equal to t power 4. So t divided by 4 minus 4 into 9.81 divided by 4. So this gives me this equation. So t power 4, t divided by 4 is nothing but 0.25t minus 9.81. So this is AB equation. This is the second equation. And for C as well, consider FBD of block C. So if you see here, we have a block C. Okay, the tension is here is 2. Okay, so here the tension is 2T. Okay, and the weight is acting downward. The weight of the block C is 6 kg. So it is 6 into 9.81. So here also I'm assuming the acceleration as upward direction AC. Okay, so in the positive. So if we have this formation, so summation of f of y will be equal to mass into AC. So here we'll have 2t minus 6 into 9.81 because weight is acting downward. Mass equal to 6 into AC. Okay, so I need the equation in the terms of AC. So AC will be equal to 2t divided by 6 minus 6 into 9.81 divided by 6. So this gives me 1 by 3, that is 1 by 3 is nothing but 0.33t minus 9.81. This is AC, the third equation. So now I'll substitute 1, 2, 3 in the first equation. Substitute equation 1, equation 2 and equation 3 in first equation. Okay, so the first equation nothing but I write it down once again, a suffix a plus a suffix b plus 2 times of a suffix c is equal to 0. So here a suffix a is 0.5t minus 9.8, 0.5t minus 9.8, then a suffix b is 0.25t plus 0.25t minus 9.81, and a suffix c is here, that is plus 2 times of 0.33t minus 9.81. This will be equal to 0. Okay, now 0.5t minus 9.81 plus 0.25t minus 9.81 plus multiply the 2, that is 0.66t minus 2 into 9.81, I'll get it as plus or negative minus 19.62. This will be equal to 0. Okay, so now we are going to add all the values, that is 0.5t plus 0.25t plus 0.66t. So I got 1.41t. So again, if you see, we have minus, minus and minus, so all are minus. I can take it to the other side, so this will be equal to plus 9.81 plus 9.81 plus 19.62. So this gives me 39.24. Okay, now we have to find the tension. Just divide that 39.24 by 1.41. So it gives me value 27.8282, or else 829. So I'm taking it as, okay, I'm taking it as 829 Newton. So this is the tension will be in each of the 3 string. Okay, now we found out the tension. After that we have to find the acceleration of the all the masses, right? So we know that from the acceleration, from the equation 1, from this equation we can find out the acceleration. So AE is equal to 0.52 minus 8.1, 9.81. So substitute T in first equation. Okay, that means A suffix A equal to 0.5 T minus 9.81. So this will give me the acceleration of A. So 0.5 into T is 27.829 minus of 9.81. So I got the value as A suffix A equal to 4.140 meter per second square. So this is positive value. Okay, right. Now again substitute T in second equation. The second equation, A suffix B equal to 0.25 T minus 9.81. So we'll see 0.25 into 27.829 minus 0.25 into 27.829 minus of 9.81. So this gives a value of AB as minus 2.852 meter per second square. That means it is going in downward direction. So we have assumed in the upward direction, but since we have a minus sign, it is going in downward direction. Okay, so this AB is going in downward direction. And similar manner, so substitute T in third equation. So AC equal to, what was the equation for AC? Okay, 0.33 T minus 9.81. So 0.33 into 27.829 minus of 9.81. So we got AC equal to minus 0.626 meter per second square. Again, so even AC also going in downward direction. The block C is also going in downward direction. Okay, so we have assumed in the upward direction, but out of three assumption, we got acceleration A in the positive direction, that is going upward, whether block B and block C's are going in downward direction. Okay, I hope you understood this problem very well. Okay, so in the next video also I'll try to solve this similar kind of problem. So I hope you will watch that video as well. If you have any doubt in the problem, you can put in the comment section. Thank you for watching.